Hey viewers, welcome to my channel. In today's video, we are going to discuss chapter 1, that is rational numbers. Before we move to the rational numbers directly, let us just understand the number system. Okay, the number system, the first category of number system is natural numbers. So the all countable numbers like 1, 2, 3 and so on, we can say it's a natural numbers. The second set of natural numbers is whole number. Can you tell what is missing in natural numbers? Yes, right. 0. So if we add 0 to the natural numbers, then it becomes a whole number. So 0, 1, 2, 3 and so on. Let us just understand the integers by taking an equation. A simple equation, okay? So x plus 18 is equal to 15. So find the value of x. So x is equal to 15 minus 18. That is minus 3. So negative number, right? So integers includes positive numbers as well as negative numbers. So we can say integer is a collection of negative numbers as well as positive numbers. Okay. So rational numbers, our main topic. Today's main topic is rational number, right? So what is rational number? Let us just take the fraction number 1.3. So how we represent this in P by Q format? 13 by 10, right? Correct? Yes. So the number which can be represented in the form of P bar Q, where Q is not equal to 0, is called rational numbers. So it's a collection of P bar Q format numbers. Okay, 1 by 3, 2 by 3. Can we say root 9? Yes. What is the value of root 9? Square root of 9? 3. Correct? So how can we represent this 3 as 3 bar 1 P bar Q format, right? Then 1, can we write it 1 bar 1 is equal to 1? Correct? So on. So I was telling P should not be equal to Q should not be equal to 0. Why? The denominator value should not be equal to 0. Let us understand in this format. Okay, 2 by 0. Okay, so let's divide 2, okay, with a value 0. So can you tell a number, okay, here, so that it multiplies with 0 and we get the answer as 2. Okay. Is there any number? No, right? It's not possible. So Q should not be equal to 0. If Q is equal to 0, then we say it as a not defined. Not defined. Okay, fine. So let us move to the properties of rational numbers. What? Properties of rational numbers. 1 second. Okay. Properties of rational numbers. The properties of the rational numbers we check with the 4 operation, that is addition, subtraction, multiplication and the division. Okay, so first property is closure property. Closure property. So with respect to addition, we are going to check now. So addition. Okay, so for any given two rational numbers, let's say A and B, whether A plus B is equal to a rational number, can we check? So let us take an example. 1 by 3 plus 2 by 3. The value is 3 by 3, which is equal to 1. Correct? 1 can we write like 1 by 1? Yes. So it's a rational number. So let us take with another example. 2 by 3 plus 1 by 5. The denominator values are different. So what we have to do? Correct. I think you are recalling LCM. So 3 and 5. We have to take the LCM of 3 and 5. So what is the value? 15. Correct? LCM of 3 comma 5 is what? 15, right? So we can write 3 into 5, which is 15. So we have to make denominator correct, same. So what we are going to do it? 15. So 3 5s are 5 3s are, right? So 2 5s are 10 plus 1 3s are 3. So 13 by 15. So 13 by 15. Again, it's a P by Q format. Can we say a rational number? So can we say a rational number is closed under addition? Yes, correct? Okay. So let's discuss the closure property with respect to subtraction. With respect to subtraction, okay? Subtraction. So for a given two rational numbers a comma b, whether a minus b a rational number or not. So let us understand in this way. So 1 minus 3 minus 2 by 3. I am taking the same example. Okay. So 3, 1 minus 2. The answer is minus 1 bar 3. Minus 1 bar 3 a rational number? Yes. So a rational closure property holds good for subtraction as well for a rational number? Yes. So we can say a rational number is closed for a subtraction as well. So the next operation is multiplication. So for multiplication, for a given two numbers a comma b, whether a cross b, like product of a and b, is a rational number or not. So same example, 1 bar 3 into 2 bar 3, the value is 2 bar 9. Okay. So 2 bar 9 is a rational number, correct? Yes. So we can say a rational number for a multiplication holds good, correct? Correct. So a rational number is closed for a multiplication. The next set of operation is division. Okay. For a given numbers a comma b, whether a division b is a rational number or not. So 1 bar 3 division 2 bar 3. So what if we are going to do? 1 bar 3. So we have to take a reciprocal, correct? 2 bar 3 becomes 3 by 2. So 3 3 gets cancelled. So value is 1 by 2. Is it a rational number? Yes, correct. So if the value is non-zero, correct. If q value is 0, okay, here, okay, if this b value is 0, then it becomes not defined. So we can say excluding, okay, excluding q, okay, that should not be called visible. Like excluding our, we can say here b, okay, excluding b is equal to 0. Excluding this, rest all the collection of rational numbers is closed under division. Okay. Okay. So the next property is commutative. Okay. So for commutative as well, we are going to check with respect to addition, subtraction, multiplication, and division. Okay. The first one is addition. So for addition, for given two numbers, that is, let's say in general a comma b, whether a plus b is equal to b plus a. Do we need to check the same? Yes. So let us take an example. So a is equal to 1 by 3, b is equal to any number like 2 by 5. We'll take 2 by 5 this time. Okay. So a plus b, how much it becomes? So 1 by 3 plus 2 by 5. We learned, right, LCM. So what we have to do? We have to take the LCM of 3 comma 5. So what is the LCM of 3 comma 5? Alright, 15. So 15. So the denominator value should be same. 3 5s are 5 3s are. So 5 plus 6. So it becomes, denominator is same now. So 11. So 11 by 15. Okay. Now we'll calculate b plus a. So b plus a is equal to 2 bar 5 plus 1 bar 3. Again, the LCM is 15. 6 plus 5 bar 15. The value is 11 by 15. It's a p by q format. Can we say a plus b is equal to b plus a? Correct. It holds good. So what we can say? Addition. Okay. The addition of rational numbers is commutative, right? Or else we can say what? A plus b, like a plus b is equal to b plus a. Means addition is commutative for a given rational numbers, right? The next one is subtraction. Subtraction. So what we have to check here now? Yes, correct. A minus b. So a minus b is equal to b minus a. So let us understand. Like let's take a in general a and b are the rational numbers. We have to check whether a minus b is equal to b minus a. So we'll go with the same number 1 bar 3. For simplicity, I think it's fine like 2 by 5. So a minus b will do it. So a minus b, a minus b. So what is the value? Right, minus 1 bar 15. So b minus a we have to calculate. B minus a, b minus a. So what is the value? 1 bar 15. See, here a minus b value is minus 1 bar 15. But here b minus a value is 1 by 15. Both are not equal. So this property doesn't hold good for subtraction. Right? Okay. The next one is multiplication. So what we have to check for the multiplication? For a given rational numbers a comma b, whether a cross b is equal to b cross a. Okay? So we'll go with the same example. A cross b we have to find out. So what we have to do? We now to take LCM. Right? So what is the value? 2 by 15. Okay. So here b cross a. So b cross a is equal to 2 by 5 into 1 by 3. 2 by 15. So a cross b is equal to b cross a. So multiplication is commutative for a given rational number. Okay. So the next one is division. Okay. For a given two rational numbers a comma b, whether a divide b is equal to b division a or not. Okay. So we'll check. A division b. So what we have to do? We have to take a reciprocal for this, right? 5 by 2, the value is 5 bar 6. Here B divide A. So what we have to do, we have to take a reciprocal of this. So 2 bar 5 into 3 bar 1. So 6 bar 5. Check whether A divide B is equal to B divide A. No, right? So division is not what we concluded here. Division is not commutative for a given rational number. Okay. So our next property is associativity. So we'll move to associativity. So first operation, addition, right? For a given two rational numbers, that is A comma B, what we have to check whether A plus B is equal to A plus B plus C, right? We have to check whether it's equal to A plus B plus C, correct? We have to check the same thing, right? So what we will do, we'll take C is equal to another number 2 by 3, okay? So what we have to do first, we have to calculate A plus B plus C. So the value is A is 1 by 3 plus 2 bar 5 plus 2 bar 3. What is the LCM of 5 and 3? It is 15. So 1 by 3 plus 15. So 5 3s are 3 5s are 2 3s are 6, 2 5s are 10, right? So value is 1 by 3 plus 16 by 15. So 3 and 15. LCM of 3 and 15. Calculate the LCM of 3 and 15. Okay. 3, 15. So 3 ones are, 3 fives are. Then 5 ones are. So again it's a 15. So 15. So 3 fives are 15. So 5 plus 16. That is 21 bar 15. Okay. 3 fives are 15. 3 sevens are 21. So 7 bar 5. So the next we have to calculate what? Next step, A plus B plus C. Okay. So 1 by 3 plus 2 bar 5 plus C value is 2 bar 3. Okay. So 15 is a LCM. Okay. Correct. So 5 plus 6 plus 2 by 3. Next. 5 plus 6 is how much? 11 plus 2 bar. So 3. So 15 and 3. The LCM of 3 and 15 is how much? 3 into 5, 15, right? Yes. So 15. So 11 plus 3 5s are 5 2s are 10. So it is 21 by 15 again. So the value is 7 by 5. So we concluded A plus B plus C is equal to A plus B plus C, a rational number. So addition is associative for a given rational number. Correct. So the next is subtraction. So what we are going to do, we are going to check whether A minus B minus C is equal to A minus B minus C. Okay. So let us quickly calculate this. Okay. So what is the value of this? It is correct. What is the value here? Minus 4 by 15. Correct. Minus 4 by 15. So what it becomes? So here let me just drop this. Okay. So here 1 by 3 minus, okay, this one minus minus plus, so 4 by 15. So again 15 is LCM. 3 5s are, so 5 plus 4, that is 9 by 15. So 3 3s are, 3 5s are, 3 by 5. So the next we have to calculate, so what we have to calculate next is A minus B minus C. Okay, so here 15 is LCM, right? 5 minus 6 minus 2 by 3 is equal to 15 minus 1 minus 2 by 3, correct? Again 15 is LCM, right? Minus 1 minus 3 is correct. 5 to the 10, right? So it is minus 11 by 15. So C, A minus B minus C value is 3 by 5 and A minus B minus C value is minus 11 by 15. So subtraction is not associative for a given rational number. So, okay. Hope you guys are understanding. Okay. Shall we move to the next operation? Okay. So, the next operation is multiplication. So, for a given two rational numbers A comma B, whether A cross B cross C is equal to A cross B cross C. Okay. So, quickly we'll calculate this value. So 1 by 3 into, here if you see 4 divided by 15, correct? 4 by 45. The next one, 2 bar 15 into 2 bar 3, that is 4 by 45. So can we say LCM equal to, sorry, can we say LHS is equal to RHS? This is, if we consider this is LHS, this is RHS. So both are equal, correct? So what we concluded here, multiplication is associative for a given rational number. The next operation is division. With what we are checking, division with respect to associative property. For a given rational numbers A comma B comma C, whether A divided by B divided by C is equal to A divided by B divided by C. Okay. A divided by B divided by C. Okay. Okay, let's calculate this quickly. Okay. 1 by 3 divide this one 2 by 5. Reciprocal of 2 by 3 is 3 by 2. Right? So 2 gets cancelled. 1 by 3 divided by 3 by 5, which is equal to, correct, 1 by 3 into 5 by 3. The value is 5 by 9. This one. 1 by 3 into 5 by 2 divided by 2 by 3. So value is 5 by 6. So if we take the reciprocal of this, it becomes 3 by 2. The value is 15 by 12. So 3 4s are 3 5s are. So 5 by 4. Check. LHS is equal to RHS? No. So what we concluded from this, the division is not associative for a given rational numbers A comma B comma C. Okay, I think my video might be bit lengthy because I'm explaining in detail. Okay, don't skip. Okay, please watch complete so that you'll understand thoroughly. So we'll move to the next topic. will understand role of 0. What is the role of 0? Okay. Can you tell what is the value of 3 plus 0? Yes, 3. What is the value of 0 plus 3? Again, it's a 3. So what we concluded here, if we add any number to 0 or vice versa, 0 to any number, we are going to get the same number. So 0 is called what? Additive identity. Got it? So next one is role of 1. Okay. Now, can you tell 3 cross 1? What is the value of product of 3 into 1? Yes, 3. 1 into 3. Again, it's a 3. So what we concluded here? So if we multiply any number with the 1 or 1 with any number, we are going to get the same number. So what we can say here, 1 is a multiplicative identity. Okay. So the next one is negative or what? Additive inverse. Okay. So the negative of 3 is minus 3. Minus 3 is negative is 3. Okay. If we add, okay, 3 with its negative value, what is the answer? Yes, 3 minus 3. You know, right? 3. So minus 3, the value is 0. Right? So if you do minus 3 plus of this, again it's a 0. Right? So a plus minus of a is equal to 0. So for a given number, if we add the negative of the same number, we are going to get the value as 0. So a, if we take a by b, okay, the same thing. Okay, minus plus minus a by b, the value will become 0. For a given a by b rational number, if we add its negative minus a by b, we are going to get 0 as an answer. Okay. So next is a, so for this we will say it as a additive inverse. Next one is a reciprocal. Reciprocal. Okay. So let's say a by b. What is the reciprocal of a by b? Yes, it's b by a. Okay. So 1 by 3. What is the reciprocal of 1 by 3? 3 by 1. Yes. If we multiply these two, okay, if we multiply these two, the answer is 1. Correct? Correct. So for, let's say this as a C bar D. Okay. So for a given rational number a comma b, there exists a reciprocal, that is C bar D. If we multiply this, the product will be 1. Okay. Okay.